So object-oriented programming is a great way to organize your code. Once again, recall that when we used objects such as lists or strings and dictionaries, we could use methods that were specifically built for these objects. Methods such as append to a list to add a new item to the list, or a method called join for a string if you wanted to combine two strings together. Right. So these objects use information about, or these methods actually use information about the objects itself and change the object or return some information about the object. Right. For example, if I said list.count and pass an parameter or pass an argument, I would either get the number of elements that are existing in the list, or I get 0. So we're getting some information back about the list using the count method. Or you can use the append method for the list to actually modify the list by adding a new element to the list, right? And so object-oriented programming is a technique or is a way to create your own objects and define your own methods and attributes for that specific object. Now, underlying these objects, they could be using lists or dictionaries or such, but essentially you are creating kind of your own custom object, one of these objects, right? And when you first start writing programs in object-oriented programming, it could get a bit confusing, especially the way the arguments are passed or variables are handled within a object in Python, or actually in any other language as well. But trust me, once you start going down the road of writing object-oriented programming, you're not going to turn back, because it's the best way to organize your code, especially when you're writing large projects. It helps you reusable in terms of creating reusable code, and if written correctly, you can actually generalize the object that you have just created, and that you could actually use over different applications or projects as well. So let's take an example of a company directory here. Say you're creating a company directory and you want to use object-oriented programming to create a personnel information, like store personnel information, right? So you could create an object that holds the name. Well, that name could be further broken down into first name and last name, contact information, and some other demographic information about that person. So that could become your own object that you can then use and pass around. And then you could actually inherit that object into other department-wide personnel information, where you can then attach information such as salary, the title, the hire date, promotion date, and so on and so forth. And we'll talk about inheritance as well. That's another key topic whenever we're talking about object-oriented programming and objects in person. So to create an object, we use something called as a class keyword. Just like we use keywords such as import or print. To create an object, we use a keyword called class. And I personally sometimes interchange the object versus class when I define or talk about object-oriented programming. But I'm going to make a conscious effort to actually call class instead of object. It's kind of a habit from my C++ days. But so let's take a look at a general syntax of an object. All right, so I'm going to switch over to my Python or Atom here, and to write an object, we'll first start with our keyword class, and then you provide some sort of an object name or a class name, right? I personally like to always use a capital case first here, so I would say something like class name, for example, right? And then everything gets indented under it. So one of the first things you want to do is actually initiate your class. So we use a special a function called underscore init, and almost always in all methods and functions that you're going to write within your class, you want to pass in this parameter called self. So, and I'll explain self in just a second. So you have your initiator of the class, and then you're going to say self dot some variable a, and you start initiating or initializing the variables that are, or variables, or yeah, you start initializing variables that you're going to use class wide. And this function init is usually called a constructor. So you're constructing or initializing your class, and when you first call the class, and then this is followed by all other methods, such as define method 1, and then we pass in a self object here. So this would be something like count method for a list, or let's call this method 1, right? And or an append method here. So these are various methods that you're going to write. Now, about this self variable. So this is a special reserved keyword, and this is a special variable, which tells Python how to differentiate between the variables that you're going to use within the class itself or within the object itself, and that object or that variable is shared across all methods, or is global within your class or global within your object, versus variables that are used outside in your main program, versus the variables that are used locally within each one of these methods that you're going to define. And it will become more clear once we start taking a look at a few one of these examples. So let's get started with that. So for now, I'm going to use an example of cars, or create a class called car and use that example along with vehicles to just get the basic understanding of how classes work or how objects are created. And then later on we'll take a case study of our old FASTQ file format parsing, and create a class for that along with various attributes and methods. So to create a class for cars, so we're going to use our keyword class first, and then we're going to give it a name car. And by default, we're gonna create a constructor or a special function called init that initializes this instance of the object that gets created, right? So we have to pass in our initial parameter self, which is actually a representative of the instance of this object itself, and then any other additional attributes that you want to pass along when you initiate your instance of this particular car. So this is kind of like passing arguments to your function. The only difference here is that the first argument, which is self, and it doesn't have to be the keyword self itself. You can use the keyword this if you come in from Java or C background and you're more comfortable with that. But I like to use self, especially in Python, Perl world, because everyone's comfortable with that. And if I pass this along to somebody else, they would understand what self is faster than this or some other variable name. So I generally stick with self. And it's a general practice or best practice to do that. And then pass along any other attributes or any other information you want to pass when you create this class or create this object called car. So for now, I'm just going to do one or two. Let's just say make and model, right? So we're going to pass in a make and a model when we initialize our instance of car, and then we're going to say self dot make is equal to make, and self dot model is equal to model. So what are we doing here? We're saying we're creating an object called cars, and when that object is initiated or defined at first, we're gonna expect 2 arguments. Now I know we're passing in 3 arguments, but again, this part is the self argument is automatically passed in, so you don't have to worry about it in terms of passing that argument, but you do have to define it here. And then you're passing in two arguments to the initialization of this process. And again, we're not going to call the init method explicitly. It's automatically called when you first initiate your instance of that object. Okay, so I'm going to save this as car. I'm going to save this in our in that folder called my first project. And you can save it wherever you want. Just so I can show you how our the properties that we've talked about in modules still hold here. So this is going to be called cars, and I'm going to say capital cars.py. So this is let's call this cars now. I'd like to keep my class name and the file name consistent just to make things easier. Okay, so now I am going to create another file, and I'm going to save this in the same location, and call this class example or object example. Let's call that .py. All right, and we're going to say import. We're going to import our cars. So just like you would import a module, you import a class here, or import an object, and we call that. And then we're going to say my car is equal to cars, and we need to pass in two arguments. So we're going to call this make, say Audi, and model S4. All right. Okay, and let's say print my underscore car dot make and my underscore car dot model. Save this. Now if I run this, it will actually not run. Well, that's correct. So the reason this is because it says module object is not callable, which is saying that it doesn't recognize what cars is so far. Although we've imported cars, well, there's no method called cars, right? There's no method within cars called cars, so that fails. You could actually alias this by saying import from our module, and you can call it the same name, and now this will work because what it does is essentially aliases an alias for cars is created here. Or if you were to just say just have this statement, then you'll have to say cars.car. And I know it's kind of confusing, but the only reason this happens is because if you just say cars like so, well, there's no function within this, right? And there is no actual attribute or there's no method within cars called car, so it doesn't know what this is. The Python doesn't know what you're calling here. But if you say cars.car, now it's saying, okay, I'm initiating my first object by the module or by the class or object called cars. So we're doing that, and when you initiate this object, we are passing in two arguments, which is the make and the model. And then we actually assigned, the instance of this object, which is now aliased. We're using my cars to use the instance of that object cars, and that instance has two attributes, that is a make and a model. And for now, that attributes are set to Audi and S4, right? So the attributes are characteristics of your class or characteristics of your object. All right, I hope that is clear. So if we run this, that works. Now if I were to create another instance, right, my car 2, and let's say cars, and actually I don't like to use that because it gets confusing, so I want to say from cars import. This makes it a lot easier, and it's kind of also the convention that I'm used to. And I'm going to call this one, it says cars dot let's see, Toyota, and we're gonna say Supra. All right, so whoops. All right, so now we've called the same function or the same object twice, but both of them have different instances, and this is where that self keyword or this keyword comes in handy, right? So every time you initiate, the self keyword is kind of going to differentiate between the instances, instance A and instance B of your object, and the variables are now being divided and are kept, separate from each other so it doesn't clash in. And now if I were to say print, if I can type correctly, print my underscore car2 dot make and my underscore car2 dot model, well, we get Toyota and Supra, right? So in our class, it's always going to be self dot make or self dot some attribute that you've defined, you wanted to define. Outside you don't have to worry about it. Because of this self keyword, or because of using this a way to represent the instance of the object, we are going to be able to Python will take care of differentiating between instance A and instance B, or one or two instances. The other thing to note in our object definition or class definition is that we have these make or these variables called multiple times, right? So these could be anything. These are just like you're passing any attribute names to a function call. It could be M or A or B or C, and then the ones to the right hand side are equated to the local variable that's passed into this function or to this method in this case. So if I call this make as A, then I can simply convert or replace that make with A. So that works. But however, the convention is in Python to keep all of these names the same, so it's a lot easier to understand that what is being passed in, what is being used, and where they are defined in terms of the instance of that object itself. So let's add few more attributes to this car class here. I'm gonna call this say cylinder, right, to represent how many cylinders are in the car, whether it's a V6 or V4, right? And let's call this horsepower and torque, right? So now I hope you start to see a problem developing. So you could have set up as many attributes as you want, but when you define them here, or when you expect them to be initiated or passed during initiation of your object, it kind of can get cumbersome, right? And you're passing in way too many objects. So I personally don't like to do this, and I'll show you an alternative to do that by using set and get methods in just a minute. But before we get there, make sure you do not forget to use your doc strings to define what we're doing here, right? Create a class or object of cars. Then we can say for this expected attributes are make, model, cylinder, V6 or V4, horsepower and torque, right? So all good. Now let's make sure we assign these attributes to this class. Cylinder, self dot horsepower, self dot torque. Okay, so I'm gonna save this and go back here, and now if I run this, it throws us an error because we're expecting 6 arguments. We're only passing in 3. Well, I'll do passing in 2, but the third one is it is passed automatically and handled by Python itself. So we still need to pass in cylinder, horsepower, and torque, right? Let's say these are V6, 340, and torque to be 420 or 480. Let's do that. And for Supras, these are usually V4. Let's call these 300 and 350, right? Actually, we can pass these as integer values too. So just so you get the idea that it doesn't have to always be strings. You can pass in integers. You can pass in Boolean values or anything else, any other data types. So as long as we handle them correctly in here, okay? All right, so if I run this, it works, and we can now say my underscore car dot, what was it, cylinder? And over here, I'm gonna pass in my underscore car 2 dot horsepower, right? So it says it's and those attributes that we've defined and now can be accessed through your object type attribute values, just like we did for list. So far we have our basic class called cars, with a constructor which is our special case init, and has a method, and this constructor method uses a self keyword which references the instance of a class, right? And for each instance, we also have multiple attributes that are passed when we initiate our instance or create our object. Now, the class could also have global attributes, right? In this case, this is a car, and car in most cases generally have 4 wheels, so it doesn't matter what the make or the model of the car is, it's always going to be four wheels, right? So we could create actually a global variable, and or what's actually called as class level or class level attributes or object level attributes. They can be defined up top right after your class declaration and your doc strings. So we can call these here. These are called class level attributes, right? And now because these are global or the same for all instances of the class, they don't need the self keyword, right? So I don't have to say self dot number of VLs, right? Because the self keyword is used to differentiate between different instances of the class. So we're gonna just call this 4, and I'm gonna call another one called base value. Let's call this 4,000. All right. So now these class level attributes are global or are common to all instances of a class. If I save this and come back here, and if I print those attributes here, so if I say my car dot number of VLs, and I do the same here, two dot number of VLs, well, they'll both print the same value because they're common and they're class level or global to any single class that we create. Right. So now let's talk about some methods in our functions here, or in our class here. So methods are functions inside the body of a class, and they can perform operations that may or may not use the attributes that we have defined. Right. So methods are actions on the object itself, and they use the self argument to perform those actions on the instance of that class. So let me call this define. I'm gonna call this value of the car, and we're gonna pass in the self parameter, which is passed in automatically. And then what I want to say is I'm going to actually say if we're going to use the attribute that may have been defined for the instance of the car. So if I say if self dot say cylinder equals well, v6, right? Then we're gonna say just say print add more to base value, and we'll implement this a little bit later. Else print base value is still, and I can just say base value here, right? Let's save this and let's go here, and now if I say print my car dot value of the car, and now because value of car is a method, we need to execute the method, which then goes and performs some operation. We have to have these parentheses at the end, right? In this case, we're not passing any additional parameters, so we don't have to pass anything. The self part is automatically passed in by Python, and I can do the same here just to show you the difference that we get, right? So we have an error here because best value, I forgot about that. So although we the base value of this car is a class level attribute, or class level attribute, which is global and is available for all instances, we still can't just simply write the variable name as such, right? We have to define it or associate it with to this class itself. So there are one of two ways to reference a class level attribute. You could either just say self dot, because again, this, although the value the value of this variable base level will not change from one instance to the other, but it's still available at every single instance, right? It's available when we said this instance the number of fields or value. So it's still available at every single instance, so you can use self dot to access the class level attributes. That's one way of doing it. However, another way of doing this is by just calling this using the class name itself. It's cars.baseValue. So for every single instance, and the instance is cars, its value or the access the class level attributes, and this only works for class level attributes where you can say class name dot the attribute name. So some people like to do this because if there are a lot of methods, and instead of having to scroll and see where the self dot attribute name was defined or declared or updated, if you just say cars dot, you know that that's the same value, or the class dot some attribute name, it's the same across all of them. So for now, I'm just going to keep this that way, cars dot, right? I'm going to save this and then come back here and run. Awesome. Actually, however, there's a bit of another thing here. So notice these none values being printed here, and that's because of this print statement. So we know that we're calling a method called value of car, right, on this object called my cars, and this method is essentially a function. So function returns something at the end, right? It always returns. By default, it returns none if there is no return value, which is the case here, unless you explicitly pass in a return value, right? So since we're not passing anything by default, this value of car method is executed. These statements are evaluated, and at the end, by default, it returns none. And since we're actually saying print whatever is being returned by this method call, this additional none value is being printed. So I'm going to remove this print statement here and run this one more time. And actually, before even I run this, I am going to move back here and modify this a little bit. So now if our number of cylinders is greater than that is equal to V6, then I'm just gonna say powerful engine value is, and then let's say I'm gonna use self here just to contrast that both cases work, and you can choose either one times 2. And if we run this, well, save this here and then run our main program, and that would work, right? So there are no nuns defined now. The none value is not being printed, which was an extra bit. And now the car value based on what the attributes were set has been defined to be either higher than the value or less than the value, or either the base price or higher than the base price based on the attributes. So that's the basics of class, or defining your own method, creating attributes and methods within those attributes, right? Actually, before we go, I'm going to do one more thing. So earlier I mentioned that I don't like to pass in these values these attributes when these are defined. I actually like to define or create something called as get and set functions, and I'm kind of spoiled between the Perl version and the C++ versions. So I'm going to show you a little trick here. So I'm going to create another method here, and I'm going to call this CMake, and we're going to pass in self, and then we're going to also pass in a attribute here which is called make of the car. And just like our function, I could actually even define default values. So I'm going to define this assign a default value of none, and then I'm going to say if my make, the attribute that's passed in is none, then my intent was to return the value. So I'm going to say return self.make. Okay. Otherwise, I am saying set the value of self.make to be equal to whatever the value was passed in. All right. And we're gonna kind of remove this guy from here. That's predefined. All set. And over here, we're gonna take this out. And now, so I can say my car dot make, or actually CMake. Let's call this Audi, right? And I am not gonna define the make of the car when I actually initiate the object, but somewhere later on down the road. And then I can say print my car dot CMake, right? So note that I am using the same function, but actually at one point in time I'm using it to set the attribute, and I'm using the same function to get the attribute. So this kind of works well in Perl environments, but by convention with the C, C++, or Java, you actually want to write these separate functions. You want to call them get methods, or it's called get make, and then, well, I shouldn't write that here. I would ideally, if you were in C, or you're coming back from C or Java environment, then you would say define, you say get make, and what this does is simply returns the value, return self dot make, and if you were to say define set make, in this case you would pass in self. Well, actually there's got to be self in both cases, and then we're going to pass in a make argument, and over here we'll just say self dot make equals make, right? So if you're coming from C, Java world, you usually see set and get functions, or setter and getter methods defined as such. In Perl, you kind of have, you can combine the two into a single value here. So if I were to do this now and still run, this will all work as well. In this case, we don't have this make method anymore, so I want to remove that, and that should take care of our issue of error message down there, right? So there, I've set my car1's make to be Audi using my set method, and then I'm using the same method call again. This time, although I've set the default value of the make to be empty, so when I don't pass in any value, I assume to return the value, and then that's where I get the Audi value return printed here, which was set over here. Just a little trick that I like to use from the Perl habit that I've developed of past recent years. Okay, so that's the basics of how to write and create your objects. Next up, we're going to look into inheritance and how we can even further the use of these reusable objects.